In this video, we're going to dive into the world of containers. Over the recent years, you might have heard terms like microservices, containers, or Docker being thrown around. We're going to break down these concepts to better understand them and learn how to use them in the cloud. So, what exactly are containers? In simple terms, containers are lightweight, portable, and self-sufficient units that contain all the necessary components to run a piece of software. You can think of having your code, system tools, libraries, binaries, runtime, and your settings tightly bundled together, providing a 100% guarantee that your application will run consistently across different environments, whether it's on your local machine, in a test, or in production environment. Before containers, deploying application was a complicated process. Applications were mostly deployed on bare metal servers or more optimistically on virtual machines, which provided some improvements but still had significant limitations. There was also a big common problem among developers. Imagine you developed an application on your laptop, it worked perfectly, but when you try to run it on somewhere else, like a testing server or the production environment, it suddenly broke and didn't work. This happened because the software versions, libraries, and the configurations on your laptop differed from those on the server. Each environment had its own unique setup, causing compatibility issues. Differences in operating system or system configuration also played a part, as some applications were fine-tuned to specific system characteristics. So, containers address these issues by packing and bundling the application with everything it needed close together. Because of this, you can be confident that a successful build of your application will run exactly the same way across different environments, whether it's on your local machine, a test server, or in production. With containers, you don't need to dedicate a server or an operating system for your application. Instead, containers can share the host operating system, allowing multiple containers to run on the same OS kernel. That means you can have one machine and one OS and run several containers, each with its own application and dependencies without affecting each other. Okay, to illustrate this, let's take a look at a simple scenario where we have 3 different containers running on a single machine. For example, we can run a Python web server with its required packages on a custom port like port 8081, alongside a Go web application with its own dependencies on port 443, and a third container running a MySQL database engine. Any container can be fully isolated or configured to be accessible from other containers. It is all up to us to decide. One cool thing is that since containers share the host OS and kernel, unlike virtual machines, they typically start within just a few seconds. So, all of this has given us a good understanding of what containers are and how they behave in different scenarios. Now that we've explored their nature and characteristics, let's see how we should create and run a container. As you might have already noticed from the previous slides, the first thing you'll need, just like with any other deployment method, is a hardware or processing unit with enough resources to run your containers efficiently. The next step is to install a container engine on your OS. A container engine is responsible for creating, running, and managing containers by interfacing with the host OS and kernel. Among the available options, Docker is the most popular choice. Docker is an open source application that streamlines building, packaging, and running containers and making any operations and action easier related to containers. Once Docker is set up, the next step is to run your container from a container image. If you'd rather not to build a container image from scratch, you can use a pre-built one from a container registry. Think of a registry as a public or private library filled with ready-to-use container images for a wide range of use cases. chances are you'll find your desired application already packaged and ready to go. Simply pull the image from the registry and you can run it in your environment within seconds, just saving time and effort in setup. Some of the most well-known container registries include Docker Hub, AWS Elastic Container Registry, Google Container Registry, and Azure Container Registry. Alright, having these concepts explained, it's a good time to know what AWS offers for such services. AWS has a service called ECS, or Elastic Container Service, that simplifies the process of running and managing containers in the cloud. Just so you know, managing containers at scale requires more than just running a few containers on a single server. You might need to have tens, hundreds, or even thousands of containers running simultaneously to support your applications. ECS helps you by orchestrating and managing the deployment, scaling, and operation of your containerized applications. It also offers another relevant service called ECR, which we just mentioned it a few seconds ago, to provide you with the appropriate space to host your own container registry and securely store your customized container images. It also gives you important features such as tagging and versioning for your created images. There are also other AWS container-focused services like AWS Fargate, which is serverless compute for containers, and Amazon EKS, which is Elastic Kubernetes Service, which we'll explore in details in future videos. Yeah, that was it for this video. We've pretty much covered the fundamental concepts for containers, including what they actually are, the problem they solve, how they work, and the tools needed to build and run them. We also touched on how AWS services like ECS and ECR can help you manage and store your containers in the cloud. We will absolutely cover these services in action in the next videos. But for now, please don't forget to subscribe to our YouTube channel and see you in the next video.